ভালো জিনিস ইউজ করে দেখছি যে কাজ ভালো হচ্ছে না। আমি ওয়েবক্যাম ইউজ করছিলাম, আলাদা আলাদা মাইক্রোফোন, তো এটা দিয়ে ক্লিয়ার বুঝে যেত। আর হচ্ছে এই যে এই কি বলে এটাকে, এখানে যে ফ্ল্যাশ লাইটের যে রিফ্লেকশন ওটাও চলে যাচ্ছিল। তো আগের ক্যামেরাটা একটু ভালো ছিল না, মানে একদম বেশি ফ্রেশ। ওটা দিলে যেটা হয় কাছ থেকে বেশি বেশি কাছে রাখলে মাথা কাটা পড়ে। হ্যাঁ, এটা আমি একটু দূরে রেখে ইউজ করতে হতো। তো দূরে নিয়ে গেলে তো আমার কথা বোঝা যায় না, আবার হেডফোন কাজ করছে না, তো আমি কি করব?
এটা আলাদা মাইক নিলে মনে হয় ভালো। হ্যাঁ, আপনার ওই হেডফোনটা না নিয়ে।
3টা হেডফোন চেঞ্জ করেছি, মানে ব্লুটুথ হেডফোন, দেন ভালো একটা হেডফোন সনির, ওটাও ই করলাম। এখন হচ্ছে লজিকের যেটা, ওটা সবগুলোতে যদি প্রবলেম হয় তাহলে কি করবো? মাইক
ম্যাডাম এতদিন তো ঠিক মতোই ছিল।
এতদিন ঠিক ছিল, বাট ক্যামেরা রেজোলিউশন বাড়ানোর জন্য জাস্ট
একটা
ওটা।
পিন মাইক্রোফোন টাইপের আছে না, যে আর কি ক্লিপের মতো আটকে রাখে?
হ্যাঁ ওইটা, হ্যাঁ ওটা আমি
ওটা
ওটাও
ইউজ
নিয়েছি,
করলে হয়তো
বাট ওটাতে হচ্ছে আমি শুনতে পাই না, ওটা দিয়ে জাস্ট বলা যাবে, মানে ওয়ান সাইডেড আর কি। আচ্ছা ওকে, নো প্রবলেম, আমরা এইভাবেই কন্টিনিউ করি, এভাবেই তো ভালো আছে, সমস্যা নেই। ঠিক আছে, এখন
এইভাবেই ঠিক আছে ম্যাম, আর
আচ্ছা
দরকার নেই।
ওকে ওকে, ওইগুলা জাস্ট ইউজলেস। Okay, so our topic is chemical kinetics, and it is very well known to you. So in this topic, we'll just study about the characteristics, some specific definition, and we'll count, or we'll determine the rate of different types of reaction depending on their order. Order means it can be first order, it can be zero order, it can be third order, second order. So we'll know how to determine the order of a reaction, and what is the order of a reaction, and what is the application of this kinetic study of a reaction. So kinetic study basically depend on the time. We'll do some reaction, but we'll count the time. With respect to the time, we'll count the reactant and product. Suppose we have reactant. Reactant means in Bangla it is called বিক্রিয়ক বলা হয়, তাই না? In Bangla বিক্রিয়ক, reactant,
Yes ma'am.
বিক্রিয়ক,
Yes ma'am.
জি ম্যাডাম।
product. Another is product. Product means utpadok maybe in Bangla. So suppose we are taking this reactant at the beginning, and after some time we'll get the product. And during this reaction, how actually they converted this reaction is converted to this P. What is the rate of the reaction? Rate means with respect to the time, how much reactant is produced, or sorry, how much product is produced, or how much reactant is reacting. Okay, that means if we count the time, product will be increased with respect to the time, and the reactant will be decreased with respect to the time, because at the beginning the reactant is higher in concentration, but after some time the reactant will be converted to the product, so the amount of product will be increased. So with respect to time, it will be decreased, it will be produced. So what is the definition of rate of a reaction? The rate of a reaction is the measurement of, is the change of concentration of the reactant or product. Okay, the change of concentration of the reactant or product with respect to time. So concentration of reactant is A, and by the start bracket, it means the concentration. The expression of concentration for a reactant A is denoted by this third bracket, right?
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
with respect to time, time means T. Time, for time we denote it by T, but for T, is it the large amount of time or small part of the time?
Small amount of
Small amount of time. That's why we just take it as a dt. That means that fraction of time or some part of the time, small time. So it will be decreased with respect to time. That's why here we have to put the negative arrow. But if we write with respect to the product, what is the rate? The definition of rate, reaction rate, that will be the concentration of product with respect to time. Here it will be plus. Actually, this plus and this minus is not the mathematical term here. It is indicating that plus means increasing and minus means decreasing. Because with respect to time, the reactant will be decreased and the product will be increased. So the definition of rate of reaction, the change of concentration of the reactant or product with respect to time. And if you want to express it in mathematical formula or in equation, then you have to write this one, and this change is equal because how much A is decreasing, that amount of product is producing. So now I'm showing you the slide. In this chapter, we'll go through this topic. The rate of a reaction, factors that affect the rate, concentration and rate, that means rate loss, order, reaction mechanism, molecularity, temperature and rate, that means the effect of temperature on the reaction rate, and from that we'll have to derive the Arrhenius equation and pseudo order reaction, and rest of the part actually is not required now for you, so we'll just ignore this part. Okay, now see the background of rate chemical kinetics. So kinetics means how fast a reaction is proceed. That means here you have to consider the time, but you don't have to consider does a reaction take place or not. That means the thermodynamics. In thermodynamics, we have to take in consideration the free energy and entropy. But in case of kinetics, we have to take the rate into the consideration. So you see, it's the free energy that is actually required in the chemical equilibrium process. A reaction will be happen or not. Then you have to focus on the free energy and the entropy. But in case of kinetics, We will just focus on the speed of a reaction. So now see here, the change in the concentration of reactants or products per unit of time. Suppose here, this one, the purple color is the reactant. And at the beginning, you see this is the x-axis and this is the y-axis. And in the along the x-axis, this is the time. And along the y-axis, this is the number of molecules. So at zero time, you can see this is the time. At zero time, the highest, which one is highest? Is purple color.
Yeah.
Highest, that means 50. The number of molecules is 50. Suppose, okay? That means A, reactant is 50. That's why here, this graph is here. Beginning from that point. But at the beginning, is there any product at 0 point? At
No,
zero
ma'am.
time, is there any product? Zero
No,
time
ma'am.
means no reaction. So at the 0 time, the product that is green color, okay, that's why this curve is pink, green. So the green is beginning from the 0. Here 0 means at 0 time, the number of molecules is 0. This 0 is for both y-axis and for both the x-axis. And at 0 time, the number of molecules is 0. So now at time t, that means when 10 seconds is gone, then what is the point? Here you can see at this point, you can see this is the point where this point, right? Right? This point?
Yes, ma'am. Yes,
This
ma'am.
is the product and this point is the
Reactant.
purple one is A. That means you can see how much product here? This more than 20, right?
More than 25.
More than
Nearly
20.
30.
Nearly 30. And this reactant is less than 30.
25.
That means more in between 20 and 30. So with increasing time, you can see the reactant is decreasing and the product is increasing. And at the after 60 seconds, the product is highest, that means 50, and the reactant is lowest, that means 0. That means the reaction is over. So this graph actually indicates the progress of a simple reaction, and it indicates that the concentration of a reactant is decreased with time and the concentration of a product is increased with the time. So we can calculate the change by this mathematical formula, that is the rate equal to change in concentration of A, that actually I have written in the whiteboard earlier. Change in concentration of A divided by change in time. Here you can see it is del T. So del T and delta T, delta T and dt is similar because D is used for the small time and delta T is also small portion of time. Okay, change in time, but the time is very small, not the total time. Okay, because we're taking just only in between this 10 or 20, suppose, or 20 to 30. So that's why this is like that. So change in concentration means A2 minus A1. A2 means if I consider these two time, then you have to take these two concentration from that. Simple, very simple. So the negative sign here, you can see in this part, the sign is used because the concentration of A is decreasing. So this reaction is for the complex reaction. So we'll not study the complex reaction. We only go through the simple reaction. That's why you don't have to think about these types of complex reaction, but you can go through just how to express the rate of a complex reaction. In case of complex reaction, there will be some more reactant, you can see, and generally these types of reaction is not occurred or is not considered. We'll just find one or two maximum, not large reactant. Okay. So in this case, the coefficient, that is with the reactant, there will be some coefficient, and this coefficient should be count in for a complex reaction, and from the balanced reaction we have to calculate. And you can see this equation here, that how actually it is expressed. This coefficient is multiplied here. It's actually for balancing these both sides. Okay, it's not important for you, and will not study the complex reaction. Just you can go through, nothing else. So this is the important part here, unit of reaction. Okay, so what should be the unit of a rate of reaction? From that equation you can guess. Can you see the concentration? And this is the time. Time has the unit of second, right?
Yes, ma'am.
Yes, ma'am.
And this concentration, we can express it in case of molarity, molality, normality, anything, but generally we prefer the molarity. It is commonly used, and you can consider the molality, anything, but in case of molality, there is a problem that you have to know about the density of that solvent. So that's why molality is not commonly used. And in case of normality, there is also some problem that you have to know the equivalent weight, and then you have to consider. So which one is the easy one? Molarity. So that's why molarity is commonly used or frequently used unit. So if I express this concentration in molarity, what will be the expression? Mole per
Liter per
divided by
second.
S, that means mole per liter per
Second.
second. So that's the unit, the mole per liter per second for gases, reactants, and products. Easily expressed as partial pressure. Okay, so it's not for gaseous. Okay, this is for gaseous. Okay. So just about this term. Here the concentration unit, the rate unit of rate is mole per liter per second. Now, what is the difference between average rate and the instantaneous rate? Average rate, the reaction rate can be calculated by two types. one is average rate, another is instantaneous rate. So yesterday there was a match, cricket match of Bangladesh, right, with Sri Lanka. Do you know?
Yes, ma'am.
Yes, ma'am.
So all of you know that there one term or one they use one term that the average run rate. So what does it mean by average run rate? Anyone? Per over. In per over, we know there are 6 balls, right?
Yes, ma'am.
And in 6 balls, one batsman can make 1 6, 1 4, and rest of the 4 ball they don't have any run. Okay, suppose can you see in one
Yes, ma'am.
over? So first ball, 6 runs. That means 6. Sorry, 6. And second ball 4. And third ball 0. Fourth ball 0. Fifth ball 2. Sixth ball 0. So total is, what is the total? 12. So what is the average run rate per over?
2
12 by 6 equal to 2.
It's 2.
What does it mean by 2? Average run rate 2. That means
প্রতি বলে রান 2 করে আছে।
per ball it is 2 run.
Yes,
But
ma'am.
exactly is it okay or correct?
No, ma'am. No, ma'am.
What is the main scenario? That at first ball he make a run of 6, but at fourth number ball or third ball he has 0 run. Average run rate or average rate of reaction will not give you the exact change. It will just give you the average idea like that. From the average run rate, you can guess that if I calculate the average run rate, then per ball has 2 run. But for a reaction, if I consider a reaction, that means per second or after each time change, what is the change of the reactant or product? Okay, in this case, we just think in this case, at first ball it is 6 and third ball it is 0. But average it is 2. So in average ball it is 2, but at instantaneous ball it is 6. It is 0. Instantaneous means at which ball how much run he has made.
Taken.
Okay. So reaction, in case of reaction rate, is the point that at that time how much change is occurred, not the average rate change. Okay. So now you can see here average rate of reaction decreases with time as concentration of reactants decreases. Instantaneous rate change in concentration of reactants or products at a given instant of time. That means at that point, what is the change? Do you understand what is the difference between average rate and instantaneous rate?
Yes, ma'am.
Yes, ma'am.
I think if you think like cricket per over or average run rate, then you can understand. So how to calculate the instantaneous rate? And since we use the instantaneous rate, that's why this delta t is converted to dt. That I was talking about. But why it is written as dt? Dt means from the integration or differentiation, you use this d, right? Small portion to determine or to express the small portion. Instantaneous rate is the rate for the small portion of time. That means at the given instant of time. So how to calculate this? You have to make the tangent. This is the tangent line, and this is the point which is overlapping with the curve. And at this point, you can see this is the instantaneous time, right?
Yes, ma'am.
But this instantaneous line, tangent line, is overlapping this point and this point, right?
Yes, ma'am.
Of this curve. So at this instantaneous time, the change of time will be t2 minus t1. And at this t1, t2, there will be the C2, that means concentration. And again, at this T1, there will be the C1. That means if you draw this one in this part, you will find at this instantaneous time, you can find another change. At this instantaneous time, you can find another change. So for each of the instantaneous time, you can find the change, the instantaneous rate. Do you understand this?
Yes, ma'am.
Is it clear? Is it clear to all of you? Any confusion?
No, ma'am.
Okay. So can I go to the next slide? Okay. Here, what does it mean by slope? Slope. In Bangla, it is called maybe
Dhal.
dhal, right? So how to calculate dhal or slope? dy by dx, change of y-axis divided by change of x-axis. So change of y-axis. What is the change of y-axis? Concentration. Change of concentration. C2
Yes,
minus
ma'am.
C1.
C1.
And what is the change of the x-axis?
X-axis.
Time.
T
Delta.
T2 minus T1. So if I consider the concentration as X, that means the reactant is X and the time is T. So instantaneous rate will be dx by dt finally, because the limit is t to 0, because here the instant time is t and it is began from the 0. So that's why the limit is that. And you can convert it dx by dt. So now some factors that affect the rate of a reaction. So factors means which can affect the reaction rate and which can change, increase or decrease, right? The factors that can affect means it can be increased, it can be decreased, it can be vanished, anything. Actually, what happened when it is increased? How can you increase the rate of a reaction? How you can decrease the rate of reaction? So in altogether, we have these 5 factors that is significantly affect the rate of a reaction. So nature of the reactants. So nature of the reactants means the rate of homogeneous reaction is higher than the heterogeneous reaction. So can you tell me what is homogeneous reaction, which is heterogeneous reaction? You should know.
Ma'am, reactant and product are in same
Homogeneous solution, homogeneous mixture.
Reactant and product are in same state.
Homogeneous means yes, for the same state, physical state. Here you can see the rate depends on the physical state of reactants, liquid, gaseous, solid. That means if all the reactants are in the same phase, then they can mix very well. If they have different, then they cannot mix very well. Then the reaction will be heterogeneous. So if we compare both homogeneous and heterogeneous reaction, which one will be faster? Which one will
Homogeneous one.
give the reaction
Homogeneous.
faster?
homogeneous.
So that's why the homogeneous reaction have the higher rate with respect to heterogeneous reaction, because they will be slower, because they have different state. If they want to mix, they have need some time, more time with respect to the homogeneous reaction. Okay, suppose you are mixing liquid into liquid, that will be very easy. But if you want to mix solid into liquid, that will take time, more time, right, to mix. So nature of reactants means the physical state of the reactants will increase or decrease the rate of a reaction. For homogeneous, it will be increased. For heterogeneous, it will be decreased. Surface area of the reactants. So surface area, you can see here, the surface area, that means volume or the area. This is maybe it's square, right? Not cubic. Is it cubic or square? Okay. Okay. Maybe square shape, right? So it has a volume of 1 meter cube and area of 6 meters square. But when you divide it into two parts, its volume is same, but area is increased 8 meters square. Why? This is the same volume particle. That means their number of molecules is same, but their area is different. Why? Any guess?
Can you repeat?
Here, this has the volume of 1 meter cube and area of 6 meters square. But when you divide it into two parts, the volume will be same, right? Volume means their total length, etc. But their area is different. Why?
Surface area increased.
Yes. Why?
ম্যাডাম এর মধ্যে নগণ্য কিছু ফাঁকা জায়গা থাকে এজন্য।
Okay.
ভিতরের কিছু অংশ সারফেস
Area
এরিয়া
means
হিসেবে কাজ করে।
surface area means here you can see this area, this area, this area. So when you divide this extra two areas
Two area.
is created, right?
Yes, ma'am.
That's why area is increased. Again, if we divide it into multiple parts, the volume should be remain same because the total number of particles is same, right? But the area is increased because here you can see one surface area, 2, 3, 4, another surface area is created. So with increasing, that means if I divide into smaller part, to smaller and smaller parts, the surface area increased because for each one, the new surface is created, right?
Yes,
Yes,
ma'am.
ma'am.
So when we have the smaller particles, that means in nano size, nanomaterial, the surface area is very high. So suppose when in 1980 or 1991, the size of computer was very large, isn't it?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Why?
The parts were big.
Yeah.
Here you can compare. Actually, in the computer, there may be some IC, right? Integrated circuit.
Yes, ma'am.
An integrated circuit is made of chemical, silicon, germanium, right? These types of semiconductor.
Yes, ma'am.
Yes,
So
ma'am.
that time they don't have the idea of nanoparticle. They use these types of particle, large type. Okay, that's why their surface area was not so high. They have to use a large size of particle. But you think if we want to use 6 meters square surface area, if you take these types of shape of particle, then you have to take a large amount of particle, right? But if your particle size is this type, how much volume should you take? 1 millimeter cube or small part? আমি বলতে যাচ্ছি এখানে 6 মিটার স্কয়ার আছে তাই না, এইটার আয়তন, সরি ক্ষেত্রফল বা এরিয়া, তাই না? আর ভলিউম কি, মানে পার্টিকেল 1 মিটার কিউবের পার্টিকেল বড়, বাট এখানেও টোটাল 1 মিটার কিউবই আছে, কিন্তু তার সারফেস এরিয়া কি অনেক বেশি না?
Yes, ma'am.
তাহলে আমার 6 মিটার স্কয়ার এরিয়ার জন্য এখান থেকে অল্প একটু নিলেই তো হয়ে যাচ্ছে, তাই না?
Yes, ma'am.
So that's the thing, that in case of semiconductor or IC preparing, they that time they use these types of large amount, but now for this area they don't have to use this large volume. They just use small portion of this volume, okay, this total particle. That's why the size is decreased nowadays because of the nanotechnology. Okay, the main
Yes,
property of the nanotechnology is that the surface area is very high for nanomaterial. This is the nanomaterial, and you can see the same volume, but their surface area is very high. Here
high.
question mark is for that particle, it is 36. So what can be this area? Infinity maybe, right? So that's the advancement of the nanotechnology, and that's why nowadays small mobile phone is in our hand because of this nanotechnology. Okay, I think you understood the thing.
Yes,
What
ma'am.
is the matter of the surface area of reactants? And reactants means if surface area is very high, the reaction rate will be very high, right?
Yes, ma'am.
Okay, so if you take these types of surface, then the reaction will be small. So if you take these types of surface, then the reaction will be fast because their surface area is very high. And why their surface area is very high? Because their particle size is very small. Is it?
Yes, ma'am.
Yes, ma'am.
Okay. Here you can see the heterogeneous reaction occurs at the interface of two phases of the reactants. If one reactant is solid, rate increases. Rate increases with increasing the surface area of a solid phase reactant. Surface area increases, area of contact between reactants increases, rate of encounter between reactants increases. Rate increases. Do you understand? Here's the
Yes.
explanation. এখানে যেটা বলছে যে যখন সারফেস এরিয়াটা সলিড হয় এবং বেশি বড় হয় মানে হেটেরোজেনাস রিঅ্যাকশনের ক্ষেত্রে তখন তাদের মধ্যে সারফেস এরিয়া বেশি হলে তাদের ইন্টারঅ্যাকশনটা বেড়ে যায় তাই না যত ইন্টারঅ্যাকশন হবে রেট তত বেড়ে যাবে না
Yes, ma'am.
right
Yes, ma'am.
now you can see the surface area increases the area of contact between reactants increases rate of encounter between reactants increases that's why rate increases okay here it is in the shortcut version but you have to explain right in detail okay so now the concentration so concentration this term is very easy if you increase the concentration the molecule will be increased the collision will be increased the reaction rate will be increased right
Yes, ma'am.
Yes, ma'am.
very easy thing to predict. That means reacting molecules must collide with proper orientation and sufficient energy. Above factor increase as concentration increases, hence rate increases. That means if you increase the number of molecules, the collision will be increased and their rate will be increased. Now, what is the temperature? This temperature effect will be discussed later also for Arrhenius equation derivation. Now you just see the effect only, not the elaborate explanation. Temperature effect is also a positive effect. It will increase the if you increase the temperature, the kinetic energy will be increased and the rate of the reaction will be increased because with increasing temperature, the molecule will be they will have the collision very properly because the movement will be increased. The velocity will be increased and more collision will be occurred and more collision will create the reaction rate faster, right?
Yes, ma'am.
So that's why here with increasing the temperature, you can see the rate is increasing, reaction rate. That means with increasing, it is increasing, exponentially increased. Why this is exponentially increased, we'll see this later. So last one is the catalyst. So catalyst have the effect. It can be positive catalyst, it can be negative catalyst, but catalyst can increase the reaction rate by decreasing the activation energy. So what is the activation energy? Activation energy is the minimum energy for a reaction.
Or reaction to start.
Yes. Minimum energy. So you can see here that this is the reactant and this is the like a hill. Okay, this point is the maximum point of energy. Okay, so this minimum and maximum, this energy actually called the activation energy. That means if you want to convert this reactant into this product, you have to overcome this energy. And if the activation energy is very high, the reaction will be very slow. So somehow, if you can make decrease the activation energy, or you can lower the activation energy, then the reaction will be faster, right?
Yes, ma'am.
If you can lower the activation energy, the reaction will be faster. So by the catalyst, you can do it. So a substance that increases the reaction rate without undergoing a chemical change itself. That means it will not participate in the reaction, but it will just make some effect to increase the rate. Provides an alternate reaction mechanism faster than mechanism in absence of catalyst. Lowers the activation energy for the chemical reaction. So that's why, what is the effect? If it lowers the activation energy, then it will increase the reaction rate. But if it increase the activation energy, then it will increase the reaction rate, right? For the positive catalyst and negative catalyst, both can be happen, right? So here you can see the example. See the catalyst, and it never participate in the reaction. It just make the it lowers the activation energy. Before it was without catalyst, it was very high. You can see the red curve, very high hill. But when you use the catalyst, the activation energy is very small. So which reaction will be faster? This one or this one?
Second
The
one.
second one.
Okay, because here the energy is very small. The hill energy barrier is very small. So this is the mechanism of catalyst. So today that's our topic, and on the next class I will start the rest of the topic. Okay. So is there any question on today's topic? Anyone? I'll give